Thank you, and we will start. I think we have 45 minutes, I hope, and I have a lot of slides, but as it was announced as a workshop, I will try to show you a demo. So people sitting in the first rows will be happier as we'll see small letters on this small screen. So now you still can move forward to see better. And yeah, let's start. I am working at Masaryk University, so if you will need more information or anything, just contact me by email or phone or whatever channel you will want. Okay, this workshop should be on working with fair data, kind of a checklist for all phases of research data lifecycle. So this is outline, and I will follow it somehow. But I have a lot of slides, and I expect you will get the slides after the session. So read them and use them as meeting notes, but I will try to make it more interactive, and will try to show you a tool called Datalet that I consider very interesting and useful for fulfilling many aspects of handling research data in fair way. So we will see. I'm brave enough to show live demo, but we will see. So first, some kind of context. We are speaking about open science in general, and in this work we will focus on data, not necessarily open data, but fair data, and somehow it's related to open source, as software is very important part of handling research data. So that's the context, and very important thing is this schema, as we will try in this session to see things related for all parts of this research life cycle. So I decided I need the presenter. This schema is somehow providing more context on relation between open data and fair data. At first, if we have all the data, all the ones and zeros somewhere, just a subset of them is managed. That means somehow know what the data are, how they were generated or collected, how to interpret them. That's the main important thing. If you don't know enough about the data to correctly interpret them, then just delete them. They are not useful. Now, in this session, we will focus on so-called fair data. That subset of managed data where we have some concrete aspects we are focusing and trying to do correctly in some concrete way. And open data are data that are openly accessible to everyone. It's very important to see that fair data are not necessarily open. It's perfectly okay if you have, for example, medicine data that are protected by some kind of authentication, as just some limited group of people that are allowed to see them can access them. By the way, fair data. Who know what's fair data and just want to know more? Okay, so just okay. So I will try to go faster in these basic things. You can see that having just digital PDF is just the basic level. Yeah? It's better than piece of paper that have to be sent physically, but it's hardly machine actionable. XSL is somehow better. It has structure, there are rows and columns, so it can be somehow handled, but often there are some colors and things useful for people, but not useful for machines. So CSV is even better, pure data, but of course you need some metadata or information how to interpret them. And things like RDF provide really precise description. So FAIR principles can be described in very concentrated way in this one slide. So findability, make them findable, and be sure the data have a persistent identifier to be identified uniquely, and common persistent identifiers like DOI often provide some infrastructure for resolving based on the ID, resolving the data themselves. Accessibility is more or less use common protocols to access the data. HTTPS, OID Connect for authentication, for example. Interpretability is the very same way, but for the very same thing, but for the data itself. That means use standard formats like DICOM, CSV, JPEG, and other things that are useful and commonly used in your research area. And reusability is more or less the thing we are working towards. And the important thing is licensing. It's very important to have clear license for anything you are publishing, as without the license you are more or less unable to use it. And very important thing is metadata. You really need metadata about creation of the data set, and if it's to be really useful, you need provenance of processing or steps of processing of the data. There are some tools that can be used. For example, FIP profile can provide you with a list of concrete requirements for the data set, and then you can specify how the concrete requirement is fulfilled. For example, if you need persistent identifier, okay, you can tell we are using DOI, for example, or handle, or any other ID. So that's the very high level overview. Now let's see other phases. The first one is planning. It's probably something you do naturally if you are going to solve some project, but now common requirement from grant agencies is we need so-called data management plan. That means some kind of description what you are going to do with your data. Why they want this? Data are important. They are basic foundation of the research, so they want to see you are handling them properly. You can do it as a document, or you can use kind of specialized tools like data storage wizard. EOSC implementation in the Czech Republic is providing you tools at address dmp.eosc.cz. You have up and running instance of Data Stewardship Wizard, and you log in with your institutional credentials, and you can use it. I have a specific section of EOSC tools at the end. Now, what should be described in a good data management plan? It's valid not only for hard sciences, but everywhere. This is example from some social sciences, handling audio and video data from interviews and transcription of the interviews. And in fact, that are kind of sensitive data. So they are describing, for example, protection of the data set, and that's something that should be planned and described in the data management plan. The description should also describe quality assurance process. Yeah? In this particular DMP, and you can see it using this persistent identifier in full, is explicitly describing who is responsible in the project for checking the data are in good shape prior publishing them with logo of the project, and that's also something you should do in your research project and have it planned and described in data management plan. So now collection of data. Basically, you can reuse some existing data, or you can create your own. Very important thing is to check the license of anything you are using and attach proper license for anything you are publishing. There is a website called RDM Kit by Elixir, and that's something that can be useful for you. In fact, this schema is from RDM Kit, and you can click on every phase of this life cycle in RDM Kit and get some tools and resources that can be useful for this particular section of it. Now I will try to start with something more practical. If we are in phase of collecting data, let's expect what happened. Okay, let's imagine we are researchers. We are researchers that have found this very nice data set produced by someone. It is okay to reuse it, as there is a license, Creative Commons CC BY version 4 license, so we can use it. This data set is stored in sandbox instance of Zenodo. It's some demo, so this data set is not in fact in a shape I wanted to publish it for real use, but for demo. So sandbox of Zenodo is something that can be useful for you. You can use it for testing, for example, also API of a repository. And Zenodo is using Invenio software platform, and that's a platform that's also used for National Repository Platform by EOSC. So you can use a very similar approach for using Zenodo and sandbox of Zenodo as for NRP or many of NRP repositories. So that's our demo data set. Another option is we are the researchers that have some magnetic resonance and we produced this data set. Just to show you how it looks like, it's a scan of someone's brain, and if we use proper software that's able to work with DICOMs, we will see how it looks like. And in fact, it's series of slides of the head, so it can be used to generate a 3D model of the brain. But as you can see, there is also a silhouette of the face. So the data are sensitive. Yeah, it's medical data, and in fact, it can be used to reconstruct the face of the proband. So kind of sensitive data. But that's not so important. Important is we have a series of binary data in DICOM format, and we can handle it somehow. I would like to show you a tool called DataLet. That's a tool based on Git and Git NX for handling of large data. So it can be used to track processing of your data. So I hope it's good enough. We will install our environment with Python virtual environment to be easily able to switch for different versions of software used. How many of you use Python and know virtual environments? Okay, most of you. Nice. So I will expect you know this tool. I installed DataLet, DataLet containers, and some package for handling of DataLet command line. And if I will use, you can use this command to have competition, argument competition on command line. Yeah, so DataLet have some integrated bash competition that can be used. Okay, DataLet is based on Git. So creating DataLet data set is similar to working with Git. In fact, it's Git. It's Git repository, but it use Git NX to be able to handle also large data. So we created the DataLet with some configuration that's prepared to create some basic structure of your dataset. That creates README, it creates a folder for your code, and we will create some folder for our inputs. As we have found the dataset in the repository, we can use it as input for our processing. So we see it's possible to download the zip archive, but I will not download it directly. I just copy the link and will use the first clever trick of datalet. I can use datalet download URL command, and it will download the archive for me. But what's important thing, it from the very beginning tracks provenance metadata. It will store the original URL, and then it can be used later to see what's the origin of the input data. And in fact, if someone else will use it, he can use datalet get command to re-download the original data, even though this big archive having more than 400 megabytes is not stored directly in the Git repository. It can be easily re-downloaded. And as we used repository that use stable persistent URLs, and repositories are expected to preserve their contents. It can be used as stable source of the input data. I can re-download again later. Now you see the archive is not stored directly in the repository. It's just symbolic link to some place in Git configuration. That's the annex. It's large file, so it tracked not directly by Git, but it's tracked by Git annex, and the file in fact is stored using some hash. It's named by hash of its content. Is anyone of you known of Git annex? Have you ever used it? Okay, so just we don't have time to go to the many details, but that's standard extension of Git that allows you to store large data on different places than directly in the Git main data storage. The interesting thing is, in this case, it's stored directly in this computer. But you can easily configure remote for Git annex data. For example, some object storage and CESNet, for example, is providing you object storages accessible by S3 gateway. And in fact, National Repository Platform is also providing S3 storages, so you can use this to store the large data, the input data set, for example, or results in S3 storages, and use Git for tracking of the rest. I can see if I ask Git annex where this archive is available, you can see it's available here on my computer, but also the origin, the web address is tracked. So I can get it from this URL also if I will remove it from this computer. In fact, I can try to show you. Let's imagine I'm working with it. I don't need this input data now, and I need space on my local storage, so I can tell it to drop it. And now I don't have any physical copy of the data. But as datalet knows where it can be re-downloaded, I can just do data.get, and I have the data back. And it's automatic. It's the metadata are stored somewhere in the repository. I don't think of it. I just do data.get, and if any copy is available, I will get it. Yeah. So that's it. Also, now I want to get the data to work with them. Again, I will not just extract data from this archive. I will use data.let at archive content command. And the thing is, I will get again provenance information tracking of the files that are extracted. They are connected with the original archive they are coming from. So again, Git is tracking the original archive as the source. And again, if I drop the content and later I do data.get, archive is downloaded, archive is unpacked, and I get the data. So for any file, I have complete provenance of the original repository where the archive is and all the steps of the processing. So that's for the collection of the data. Then we have to somehow process and analyze the data. We have many tools. One of useful one is Jupyter Notebook. Do you know Jupyter Notebook? Yeah, okay. That's nice tools that that's combining the description of the data and the code, and in fact also the results. So that's something we are trying to do for handling fair data. Yeah, you have the description and the precise code and the results in one package, so you can easily see the precise processing of the data. You can see the results. You can easily modify the code and see what happens if the processing is somehow changed. You can use your own input data and see what will be the results of the processing of your own data with the code you get. And what's very important, and that's also the aim of data.let, is data processing reproducibility. Yeah, you can have the same inputs. You can want availability of the code and configuration and everything, and be able to recompute the same outputs to see whether the method really works as expected, and you get the same results. So data.let is something I am showing just now, and also one useful tool is OneData that can be used to distribute large data sets among very distributed data centers. I think we have seen some presentation on it yesterday. So these are tools for support of processing data. Back to our demo. You have seen we get some input DICOM data from magnetic resonance, but it's possible we need it in a different format. Nifty is often used, and we have seen we have just kind of binary kind of binary data. we would like metadata in JSON format to be easily used. We need some tool for working with this, and the tool is DICOM 2 nits. That tool can be used for the conversion. I will try to show you the home page, but as you can see, I have prepared the command for downloading it. It's kind of standard tool for handling this data. Yeah, there is documentation. So again, I am using download URL command to track provenance of this tool. If we are adding our own files, I can use data-let save command. That's a combination of git add and git commit. There is no staging area, just data-let save will save data-let save will save the current status of the dataset. And we see its regular Git repository. Yeah? You can see the commits. Use standard Git tools for working with it. For conversion, in fact, I will prepare some kind of wrapper. To be able to work with better. And this wrapper is working. The wrapper is prepared to be able to specify on the command line just input and output directory, and have the configuration of the tool somewhere in some script, not to be forced to write all the configuration parameters again and again. Now the important thing is that data-let is able to track not only the data themselves, but also their processing. So instead of just running the conversion script on some input and output directory, I will use data-let run command with again some comment that will be used to describe it in the Git history. I will specify the input files. Why it's specified for data-let. As you have seen, the data can be unavailable on my computer. If I will use data-let drop, the data are not physically accessible on my computer. So if I specify the inputs, data-let will make sure that the input data are redownloaded or made available for processing before the command itself is started. And I also specify output again to make datalet sure that the output location is ready for the processing, and then I will specify what should be run. I'm running the wrapper we have just prepared on input directory and storing the outputs to the output directory. Now, if I run the datalet run, the processing is done. You can see it's working on several hundred of DICOM files. The processing is done. And at the end of the processing, datalet will save the current screenshot of the current snapshot of the dataset. So if I will look to the Git history, I can see I have here a new commit with this commit ID. It can be seen it was generated by datalet, and in the commit message I see I have details of the processing. I see the command that was used, I see the inputs and outputs, and of course the process data that were generated are also part of this. So again, if I can see what's the history, the complete provenance information of some file, any file, for example, of this JSON metadata, I have it. I see exact command that was used to generate it, and as I know what are input data, and input data have tracked history from the archive in the repository, extraction from the archive, and all things, I have really precise, complete provenance information of all steps of generating the outputs. And in fact, I don't have to use datalet run. I can use datalet container run and use, for example, Docker or Singularity container. And datalet again have commands that download the precise image and are running on the local copy of the image. So again, I have stored the image itself. I'm not hoping that the image on the Docker Hub will preserve and the tag or the version is not changed by the author of the image. I have the image itself stored in the history, and I have snapshot not only of the command but also all the libraries and precise versions of everything. In fact, I prepared the wrapper in a way that is not anonymizing metadata. The DICOM contains sensitive informations like name of the proband and place where it was done, etc. So I can decide it will be better to anonymize it. So I now change just this configuration parameter of the conversion tool and save it. So now I have changed version of the conversion script. And now another kind of magic. As I know that the processing was done in this commit, now I can do just data let rerun, specifying the concrete commit when the command was run, and it will do the very same processing on the same input files with the same command again. And again, we'll make sure that the outputs are saved as another commit in the version history. So I can easily evolve the processing and make sure that all input paths and other things are the very same, and see easily what changed. You can see it's chained with the previous commit. So I see it's rerun of some previous action. I again see the command and inputs, and can see that the metadata were changed. And if I see what really changed between the first and the second run, yes, probably potentially sensitive metadata were removed from the outputs. And if I look at the history of some file, now I see it was firstly generated in this commit and then changed in this second commit. I have really precise provenance information of processing of everything. And we are slowly running out of time. So that was kind of demo what we want to do with the data. Yeah, we want to have precise identification of the input, for example by DOI or some persistent identifier. We download it from stable place from the repository. Now we have precise evidence of processing. In fact, I can then push this repository, for example, for GitHub. This is the very similar processing I prepared in preparation of this workshop yesterday. And what's the important thing? If I am another researcher that just found this nice processing pipeline on GitHub, I just copy the URL. Now let's pretend we are another researcher on completely different computer with datalet installed. I will clone the dataset. On GitHub is just Git repository. There is no annex data. Yeah. So if I will see, for example, for inputs, you can see there is just symbolic link with that's referencing some object that not exist. But I have the complete provenance history. Yeah, so everything can be re-downloaded and recreated. So the only thing I need to do is I will see the commit ID of the last processing, and if I will do data let rerun, it will do re-download of the archive from the repository, extracting the input data, processing the input data, and regenerating outputs with just one command. Yeah, everything is inside of metadata in the history. I have really precise information of what happened, And now I have everything back, and you can see Git is not indicating any change. So I generated really the very same outputs. The hash of the outputs are the same. I get everything what the original researcher generated, and it was done on my own computer. I trust my software. There are no bad tricks to get nicely looking results. I have recomputed and it worked. Yeah. So that's something that can be used to handle data in a really fair way, and you can see software is important part of it. So that was it, more or less. We are slowly running out of time, so just a few quick overview of the rest of the slides. Preserving, you have seen it. You need repository optimally with persistent ID and some storage that's stable. For sharing and reuse, again, we have seen it. You can share the processing pipeline as a Git repository for GitHub, for example, and you can use data-led, for example, data-led I will go back here with proper configuration. Yeah, export archive, sorry. You can use data-led export archive and export the snapshot with, without history, but the snapshot of the current commit as zip archive, for example, that can be uploaded to the repository. Yeah. For example, back to the Zenodo, in the README should be indicated how to handle it, and where are the original data, and where get data-led, and where is the Git processing. But the output itself can be archived, for example, in NRP repository. And data-led, again, as part of the export archive command is getting all the data, also the big files from Git annex, and it will prepare a single archive that can be uploaded to the repository, for example. And in fact, that's the very same thing we have used at the very beginning. Yeah. You have seen we used zip archive from the repository, and your processing now will be another archive in the repository that can be used by someone else as input for their own research. I think now you will have some presentation of persistent identifiers, so I will skip it. And the rest is about infrastructure that is built by EOSC here in the Czech Republic. But I think this demo was more useful for you, hopefully. So that's all from me. If you have any questions, please ask. And I hope I was not too long. Thank you.